Take the last hot meal you ate. Maybe it was eggs, pasta, rice, steak, soup, doesn't matter. You took raw ingredients, put them near heat, waited a few minutes, and ate. Nothing about that feels revolutionary. But take cooking away and your entire relationship with food changes. Meat gets tougher, starches become harder to access. Some plants stay toxic. Your teeth have to do more work, your gut has to do more work, and every calorie costs more effort to get. Because cooking does something strange that we barely notice anymore. It starts digesting your food before you even put it in your mouth. And at some point in human history, somebody figured that out. Not Homo sapiens, not someone living in a village, not a farmer standing over a clay pot. Humans were cooking hundreds of thousands of years before our species even existed. The question is why? Why take food that was already edible, put it near one of the most dangerous things in nature, wait for it to change, and then eat it? And the answer may be one of the biggest reasons human beings became the kind of animal we are today. Before there were cooks, there were butchers. By at least 2.6 million years ago, early humans were using sharp stone flakes to cut meat from animals and smash open bones. Later, stone tools became more sophisticated, and food itself could be sliced, pounded, crushed, and softened before anyone swallowed it. That matters because chewing is expensive. Imagine killing an animal, finally getting the meat, and then spending forever trying to tear it apart with teeth that aren't built like a lion's. Humans don't have enormous carnivore jaws. We don't have teeth designed to rip through hide. And over human evolution, something even stranger happened. Our bodies and brains became larger while our teeth and chewing apparatus became smaller. Homo erectus, appearing around 1.9 million years ago, had a more human-like body, an expanded brain case, and smaller chewing structures than earlier hominins. Researchers still debate exactly what diet made that combination possible. Meat eating and cutting or pounding food with stone tools probably mattered enormously. One influential hypothesis argues that cooking eventually mattered just as much, or more. And this is where the archaeology gets frustrating. Fire disappears, wood burns, ash blows away, camps get flooded, buried, trampled, and reused. So we're trying to reconstruct one of the most important technologies in human history from blackened fragments that survived hundreds of thousands of years underground. At Wonderwork Cave in South Africa, researchers found ash and burned material about 1 million years old, evidence that early humans were using fire deep inside the cave. But a fire and a cooked meal are not automatically the same thing. Then you get to a place called Gesher Benot Ya'aqov in what is now Israel. People were repeatedly using hearths there about 790,000 years ago. Archaeologists found burned flint, seeds, and wood concentrated around these fire locations. And then they found the fish. Thousands and thousands of remains from large freshwater fish. Researchers studied fish teeth from the site and found evidence that they had been exposed to controlled, relatively low temperatures, rather than simply being thrown into an uncontrolled blaze. Their conclusion was extraordinary. Humans were deliberately cooking fish about 780,000 years ago. That's the oldest direct evidence of cooking currently known, and it happened almost 500,000 years before the earliest Homo sapiens appear in the fossil record. So whoever stood over that fire wasn't us. But they were already doing something you did this week, taking food and transforming it with heat. Now the obvious explanation is taste. Cooked meat tastes better, cooked roots get softer. And sure, preference probably helped, but taste doesn't explain why cooking became so important that today, every known human culture processes food extensively, and why it is one of the most universal features of human life. The first enormous payoff was energy. Food contains calories, but having energy inside something doesn't mean your body can efficiently get all of it. A raw starch granule is locked inside plant structures. Proteins are folded into complex shapes. Cells and connective tissues physically resist digestion. Heat starts breaking those structures apart before your stomach ever sees them. Starches gelatinize, proteins denature, fibers soften. Experiments have shown that thermal processing can increase the net energy animals obtain from foods. In a controlled mouse study, cooked meat and cooked starchy tubers produced greater energetic returns than raw versions, with cooking outperforming pounding alone. So the fire wasn't merely making dinner taste good, it was doing part of the digestive work outside the body. Think of it like an external stomach. Instead of building enormous jaws and an enormous digestive system to attack difficult food after you swallowed it, you could attack the food first. Cut it, pound it, heat it, then let your body finish the job. And suddenly the same landscape contains more usable food than it did yesterday. But calories are only the beginning. Cooking also changes time. Try chewing tough raw meat and fibrous wild plants all day. Our primate relatives spend enormous amounts of their lives obtaining, processing, and chewing food. Humans are unusual because food preparation lets our mouths do less of that mechanical work. Experiments with meat and root vegetables have shown that slicing and pounding alone can dramatically reduce the chewing effort required. Cooking adds another layer of processing on top of that, and time is survival. If getting your calories takes less chewing and digestion, those hours become available for something else. Making tools, finding food, caring for children, moving camp, watching predators, talking, sleeping, doing absolutely anything except sitting there trying to turn a root into paste with your molars. This is where anthropologist Richard Wrangham's famous cooking hypothesis comes in. Wrangham argues that habitual cooking may extend all the way back toward the emergence of Homo erectus around 1.9 million years ago, and that the energetic benefits of cooked food helped support changes such as larger bodies and brains alongside smaller guts and teeth. It's a provocative idea, and it is not a settled fact. The strongest direct archaeological evidence for cooking is much younger, and research shows that eating more meat plus cutting and pounding food could already have reduced chewing demands before habitual cooking became widespread. So scientists are still arguing over how early the cooking revolution really began and how much of our anatomy it explains. But that debate almost makes the story better, because whether cooking began close to 2 million years ago or became habitual later, once humans depended on it, something fundamental changed. Food was no longer just something you found. It became something you processed into a new form. A hard underground plant could become soft. Foods that were difficult to digest became easier. Heating could neutralize some naturally occurring plant toxins and expand the range of resources early humans could exploit. The environment hadn't changed. The fire changed what counted as food. That's an absurd advantage. Two animals can walk through the same landscape and see completely different menus. One sees hard root, tough meat, an edible plant. The other sees dinner, maybe dinner after 20 minutes over coals. And then cooking creates another strange thing. A schedule. Raw food can be eaten whenever you get it. Cooking works better when you bring food somewhere, maintain heat, weight, and gather around the same place. Now there is a center, a hearth. At sites like Gesher Benot Ya'aqov, repeated concentrations of burned material show that fires occupied particular areas rather than appearing randomly everywhere. Researchers have suggested that early hearths could have served not only for food and warmth, but also as places for sharing, safety, information, and social interaction. And just think about what that does to a group. Someone comes back with meat, someone else has gathered plants. The food ends up near the same fire. People wait, and while they wait, they're looking at each other. That doesn't prove cooking invented conversation, families, or social cooperation. Those claims go far beyond what burnt stones can tell us. But once a group repeatedly depends on a hearth, the fire becomes more than a tool. It becomes a place. And humans are very good at building their lives around places. Eventually, we became so good at fire that we didn't merely preserve flames we found. We learned to create them. And even that transition turns out to be astonishingly old. Research published in 2025 described evidence from Barnum in England suggesting humans were deliberately making fire about 400,000 years ago. Researchers found heated sediments and fire-cracked artifacts alongside pieces of pyrite, the kind of mineral later humans used with flint to produce sparks. If the interpretation holds, it is the earliest evidence yet that humans weren't simply capturing natural fire. They could produce fire when they needed it. That is a massive difference. A group that depends on lightning or wildfire has access to heat when nature gives permission. A group that can make fire has heat on demand. Dinner is no longer controlled by the weather. And once cooking becomes reliable, human evolution enters a bizarre loop. We change the food changes us. We get better at processing it. Our technology changes, our diet changes, our daily schedule changes, and eventually, human beings reach the point where cooking becomes so normal that eating everything raw feels like the strange behavior. Today, you walk into a kitchen and you're surrounded by the descendants of that first idea: oven, stove, microwave, toaster, pressure cooker, air fryer. Every single one is just a more elaborate machine for doing the same fundamental thing. Use energy outside your body so your body has less work to do inside. And that's probably the wrong way to think about the invention of cooking in the first place. There may never have been one genius who looked at a fire and suddenly understood nutrition. The first cooked foods could have been accidents. Food dropped near coals. An animal burned in a natural fire. Roots heated underground. We will probably never know. What we can see is what happened afterwards. People kept doing it. By roughly 780,000 years ago, at least one human population was deliberately cooking fish. Later, controlled hearths became increasingly visible across the archaeological record, and eventually cooking becomes universal enough that our species builds entire rooms around it. The kitchen feels ordinary because the experiment worked too well. Tonight, you'll take something your body would have had to fight much harder to process, put it into a machine, heat it, soften it, chemically transform it, and eat the result without thinking twice. But underneath that dinner is one of the oldest tricks in the human playbook. Don't make the body solve every problem. Move part of the problem into the world. A sharp rock becomes an external tooth. A container becomes an external stomach. And fire becomes an external digestive system. Ancient humans didn't just learn how to cook food. They learned how to make the world do part of the work for them. And we've basically been doing that ever since.